Well, thank you for joining me on exercise 3G. I'll be looking at question 5A. This says, given the complex number z equals a plus bi, so z is a complex number and a and b are both real numbers. Find the relationship between a and b such that when you take our complex number and divide it by 2 plus I, that is an element of the real numbers. Now, when you see this as an element of the real numbers, what that is saying is that the imaginary part of z over, let me just say, the imaginary part of this expression z over 2 plus I is actually going to be 0. So if the imaginary part is 0, then z over 2 plus I is in fact an element of the real numbers and not an element of the complex numbers. Okay, so let's have a look at taking z plus, replace z with a plus bi, divide by 2 plus I. Now to cancel that 2 plus I, we have to multiply by its conjugate. So if we've got a plus here, we need a minus here. So instead of 2 plus I, we'll have 2 minus I, 2 minus I. So let's expand this. We get 2a minus ai. We get plus 2bi, and we get a minus bi squared over. Now this is a difference of 2 squared, so 2 squared is 4 and minus I squared. Now we can replace the I squareds because I squared in complex numbers is -1. Therefore we've got a negative bi squared there. We will change that to negative b times -1, change that to b, and we've got I squared underneath. Let's change that to -1. So on the numerator, the real component 2a, or not yet, let's just replace. So we've got 2a minus ai plus 2bi, change that to be plus b, change that to be 4 minus -1, and that's 5. So our denominator is 5, and our real components are 2a plus b over 5, and 2b minus a. If I factorize the I out here, we've got a 2b and a minus a that factorize, and that's also over 5. And what we said at the start was for this value to be a real number, then this component has to equal 0. So let's state, therefore, since z over 2 plus I is an element of the real numbers, therefore our imaginary component has to be 0. So our imaginary component is 2b minus a over 5. That's the imaginary component, and that has to equal 0. So let's solve this, and then we're finished. So we will multiply by 5, therefore 2b minus a equals 0, and then take the a across, therefore a equals 2b. And there is the relationship between a and b. A must be double b so that our fraction z over 2 plus I is a real number. I hope this has helped. Until next time, stay happy.